In this video, we look at logarithmic differentiation. Now, logarithmic differentiation is different from the other methods that we've studied. It doesn't have a template like the product, the quotient rule, or the chain rule does. It doesn't have a form that, say, the derivative of a trigonometric function does. What it is it's a method for taking the derivative of functions raised to the power of functions. That is f of x raised to the power of g of x, or I will show you some examples. Now I've listed the 5 steps that are the algorithm for taking. The first one is that we're going to take the natural logarithm of both sides, or we're going to ln both sides. We then use our laws of logarithms to bring the exponent down. Remember that if we have log of x to the n, that is the same as bringing that n down and multiplying. We then take the derivative of both sides using implicit differentiation. We isolate for our derivative term, and then we make a substitution back for what y is to explicitly write our derivative in terms of x. So looking at this first example, we have y equals x to the power of x. I'm going to take the ln of both sides. Now, we could take the log of both sides, but we know that this derivative is not as nice as ln of x, right? Ln of x has a nice derivative of 1 over x, whereas the derivative of log base ax has an additional ln a in the denominator. We then use our laws of logarithms to bring down the exponent of x, and then we take the derivative of both sides. The derivative of ln of its argument is 1 over its argument times the derivative of the argument. And then on the right-hand side, I can see that I have a product rule. So the derivative of the first function is 1 times the second as is, plus take the derivative of ln of something, which is 1 over x, and then multiply by the derivative of x is just 1, so I'm not going to write it. And then multiply by the first term, which is x as is. This does simplify. So this will be 1 over y times y prime equals the ln of x plus 1. We then isolate for that y prime term by multiplying each side by y. And then my final step, we make the substitution back for what y was. And if we go back up here, remember that y is x to the x. And so from there, I can get my final answer that the derivative of this function is x to the power of x times the ln of x plus 1. Looking at one more example in this video, we'll look at x to the power of sine x. So we start off by taking the natural logarithm of both sides. We can then bring the exponent down and multiply. We then differentiate both sides. This is a product rule on the right. So the derivative of sine is cosine times the second as is, plus take the derivative of the second, multiply by the first as is. I'll then multiply both sides of the equation by y to isolate for the derivative. And then finally, I will make the substitution for y, that in the original y was x to the sine x. And so my derivative is x to the power of sine x multiplied by cos x times line of x plus sine x over x.